Hi, everyone. My name is Amberly. If you hadn't heard me speak a little bit ago, you might have wondered whether or not I was able to communicate verbally, and clearly I am. If you're also able to communicate verbally on a daily basis, just imagine for a minute that you're not. Maybe you got laryngitis and you lost your voice and you had to write notes on a piece of paper or just message on your phone. Or maybe you've even traveled abroad to a place where you couldn't speak the language. Perhaps you relied on translation phrasebooks or physical gestures. These are temporary inconveniences where you're temporarily inconvenienced with your language and communication. But imagine that that's not a temporary problem for you anymore. Does anyone here know anyone who communicates primarily non-verbally? Yeah. Ability is a spectrum. Disability is not a binary state of being. During our lives, we all flow along a spectrum of abilities. Aging, for example, is an experience that we all have in common that will affect our abilities in different ways. Some people are born with particular physical or cognitive challenges. The way I introduced myself to you is actually rather similar to the way my sister would introduce herself to you. She can only say the word mama. As we grew up together, I watched her move from needing to point to printed pictures to communicate to using touchscreen devices that use text-to-speech functionality. Both of those are examples of augmentative and alternative communication, or AAC, which basically means all kinds of communication that are nonverbal. Many AAC software solutions are out of reach to users across the globe, particularly in low and middle income countries, where only around 5 to 15% of the people who require assistive solutions have access to them. Some of the reasons for that include, of course, cost. Historically, the cost of some of the available software could be prohibitive, and you need hardware to run the software. Limited language support. This is also growing, but historically that's been limited, particularly for speakers of other languages other than English. And ecosystem. Many apps are tied into particular app stores or on proprietary hardware and proprietary systems. Portability. Say you're using a solution that's on an iOS device and you no longer have access to your iOS device. You wouldn't be able to port over easily to, say, an Android app or to easily use it on the web browser in most cases. The person who first envisioned the project I'm going to tell you about did not grow up with a nonverbal sibling like I did. He actually saw a YouTube video of a girl with autism who was unable to communicate verbally. And it wasn't until she was about 10 years old that she found that she could communicate by typing one key on a keyboard at a time. He found it really difficult to believe that there could be such a disparity between what's going on inside someone's head and what they can express externally. His first language is Hebrew. At the time he started thinking about this problem, he was able to find only one main communication app that supported Hebrew, and it cost several $100s. He was really frustrated by that, and then he was inspired. What if he could make a free web-based alternative? This is Cboard, and those are the problems we're trying to solve. I used a version of Cboard to introduce myself to you earlier, just a few minutes ago. By taking advantage of the thriving open source ecosystem, modern browser API development, and then tying it all together with progressive web apps, we're trying to build a free, multilingual, open source, web-based communication alternative that is device and platform independent and offline ready. First, I'll do sort of a basic dive into a couple of the web APIs that are making it possible to sort of dream about this open AAC experience. And then we'll tie it all together with the progressive web app concept. The challenge of artificially producing human speech is not new. Speech recognition and synthesis tools have been available for some time and are constantly improving, from voice dictation software to screen reader software. The development of a browser-based API, while still experimental and non-standard, makes it possible to look toward producing web services that have a lower barrier to entry, to develop and use speech interfaces in products and services. The Web Speech API provides an interface for speech recognition, speech to text, and speech synthesis, text to speech. You may mostly be familiar with the speech recognition piece through tools like Cortana, Alexa. With Cboard, though, we're primarily concerned with the text to speech. Using the API, we can retrieve information about available voices on the device that could be coming from the operating system or the browser. And we can use the API to start and pause speech and to tell the device what to say and how to say it. So I'll do just a little bit of an introduction to to each of the APIs. We'll take a quick look first at interfacing with the speech synthesis interface. First, we'll check to make sure we have access to the API, and for conversation purposes here, we'll assume that we do. We can use the speech synthesis utterance interface to create a speech request. At base, all you need is a string that you want to verbalize. We can use the speak method to queue up our message, and the machine will verbalize it for us. This will use a default voice because we haven't specified. Through the API, you can get access to any of the available voices on the device. Again, that could be through the operating system or the browser. And then we can start doing interesting things like getting voices that are tailored for English or tailored for Spanish, depending on the language of the user. You can modify the different utterances. Here, I'm lowering the pitch just a little bit from the default. You can increase the rate, lower the volume, so that you can tailor speech to how you want to come across. And the previous example, again, on my computer, the default would be English, so I input a string of hello, and it would verbalize hello with an English voice. In this case, if we wanted to say something in Spanish, hola, we could instead specify the language, in this case, ES, Spain, or Spanish, Spain locale. And here I'm assuming that we return more than one Spanish voice when we were gathering voices earlier. So we can specify whichever voice we want. This time when we use the speak method to verbalize the string, it'll say hola with a Spanish voice of our choice. So that's the basic how we're providing text-to-speech. Let's talk about multi-language support. We need to be able to vocalize in the user's chosen language, but we also need to be able to handle multiple languages and translations, and translating things into locale-specific instances. For this, we need the internationalization API. Internationalization is the process of creating something that will work well or can easily be adapted for users from different cultures and regions, or people who speak in a different language. The API provides functionality for 3 key areas: string comparison, number formatting, and date and time formatting. And I use the word locale. Locale refers to variations in linguistic and cultural expectations and preferences that are regional. And again, internationalization is the process of catering to those different locales. Locales are defined by language tags that minimally contain a primary language code, which would be like EN for English. And it could also include a country code, like US for US English, or GB for British English. I'm just going to do walk through a very quick example of a date localization. We can create a new date for today, and assuming we have access to the internationalization API, we can use the date-time format method and specify the EN US locale to generate a date that is localized for English US. In this case, it'll return the month first, as we expect, 5/7/2018. We can optionally provide different options, like here, providing year and day as numeric and month and weekday as long. So using the same method, but providing these options instead of 5/7/2018, will receive Monday, May 7th. Using the exact same thing, but supplying the German locale, will instead get Montag 7 Mai. Sorry for any German speakers. And these are helpful, but the internationalization API is not an internationalization framework. For that, we use Format.js, which is the collection of libraries that build on the utilities that are provided by the internationalization API. We're using the React integration library, React International. So first, I'm using the add locale data method from React International to selectively load locale data only for the languages that we're supporting. I have this small demo. Earlier we said hello. And we changed our options.
Hello.
Say we want to, again, say hello in Spanish instead. We can have speech localized for Spanish. And the way that we're, again, accomplishing that is first through registering this locale data. And that includes information like how we formatted the dates earlier. Then for each locale we support, in this setup I have a JSON file providing different translations. So for example, we saw ¿Qué quieres decir? What would you like to say? And in English, what would you like to say? When we have the locale set to ES, it'll pull from the translated strings from the ES JSON file. So now we need these translations and locale settings to be accessible to our app. The library provides an international provider component to wrap our app, which provides the internationalization context and functionality that allows us to toggle back and forth between languages. It provides a way to format content, in this case, formatted message component. And here we're passing an ID of app.today and a default message of today. So if there's no translation supplied, it'll automatically return a default message of today. But in our translation files, say we've selected en, app.today will refer to today as we expect. And if we have our locale set to ES, it'll refer to app.today as hoy. So now, if we provide these translations to the international provider through messages and also specify our locale, we'll get hoy for today as we expect. So it's very cool that these developing modern browser APIs are providing us with this functionality for text-to-speech and internationalizing strings, dates, numbers, etc. But let's tie it all together, talking a little bit about how progressive web apps are solving some problems for us in providing a reliable experience and democratizing access to some of these AAC solutions. As many of you know, progressive web apps are regular sites that take advantage of modern browser features to develop a web experience similar to native apps. This concept ends up being the key puzzle piece in our attempt to build something that solves these gaps that we talked about earlier. Creating it as a PWA, we can tie together this modern browser functionality and also make it available cross-browser and cross-platform for users that don't necessarily have access to a particular device that can use a particular app from the iOS App Store, etc. It supports our goals of being device agnostic because you need a device that can run a modern browser, and that's all. and it's not limited to a particular OS or a particular brand of hardware. It's secure, because PWAs need to run under HTTPS. It provides a reliable offline experience. If you think about it, if your speech was limited to when you had Wi-Fi access or cell access, that would be pretty frustrating. And PWAs should gracefully handle limited or challenging connectivity situations. It's performant. Again, tying back to that WHO stat earlier with 5 to 15% of people not having access to assistive tech. It needs to be as performant as possible to operate under challenging conditions, whether that's internet speeds or unreliable network conditions. And lower barrier to access. Again, with no need for a particular app store, all you need is a link and you're good to go. And an app-like experience. A lot of the things, this ties back to some of what we just talked about, but a lot of the things that are great about the existing AAC apps, for example, that they're offline ready, that's not necessarily tied to connectivity. Those are things that we can take advantage of, tying together the web and an app-like experience using progressive web apps. So these concepts all weave together to support our vision of a communication solution that is as accessible as possible to as many people as possible. We believe the future of AAC is open. It might sound interesting, but a lot of the functionality of these modern browser APIs weren't accessible for people to really use and develop on. And opening it up in the web browser is really exciting. There's so much going on in this space. I had mentioned earlier that the person who envisioned this project could only find one Hebrew option when he was looking a couple years ago. And with the way the web is moving, there are so many more solutions now. Our project is one small part of that. So yes, we're very excited about the concept, the idea of bringing AAC solutions to the other 75% of people around the world who maybe previously weren't able to communicate and weren't able to access those solutions. So, thank you very much.